All right, now we're actually recording. Good, good. All right, so today solving rational equations. Yesterday we were multiplying. Here we have some addition to work with, but I actually really like this because it's much easier than if we just had an expression. Like without the equation, we have to simplify this. You have to find the common denominator. With that special one, you multiply top and bottom. Remember that process? So if this was just an expression, remember expressions just don't, they're the same things but without any equal sign. If I need to find my two common denominators, I'd probably go with 4. How'd you go from 4 to 4? Multiply by 1. Same on the top. How do you do from 2 to 4? Multiply by 2. Same on the top. So you'd end up here and then simplify it to the final answer, right? This involved us putting, compensating and changing the denominator and the numerator. But when we are dealing with rational equations, you just have to find the common denominator after factoring and simplifying. Find a common denominator. You're just going to multiply all the fractions by the least common denominator, not top and bottom. You actually end up just multiplying it to the numerator. So if you look between these, 2, 4, and 8, common denominator, I always look to what? The biggest number and see if the others fit into it. And 8 is the biggest number here. 4 times 2 is 8. 2 times 4 is 8. So I know 8 will work. Least common denominator is 8. That's easy. Looking at that, look what I did. I just multiplied each fraction by 8. I don't multiply it in and keep it grouped like this, because what can we do? First off, what's the easiest thing to kind of cancel out? What do you see? The 8's over here, right? So when we have equations, all we have to do is multiply our least common denominator to the top. We don't do it top and bottom. Reason, you'll see why. Cancels there. 8 times 1, 8 over 2, plus 8 times 3, 24 over 4. You could have reduced it there already, that's fine. Okay, 8 divided by 2? 4. 24 divided by 4 is? 6. So x is 10. Okay. So it's much easier because actually it's much easier than what we had to do when we have just expressions. When we just have to simplify, it's actually harder because you have to multiply top and bottom. But we don't have that. We have an equation. So let's see, we multiply by the least common denominator we reduced. You solve for x. There may be a few methods to use. And then the last thing is check for extraneous situations. So whatever value you get for x, you got to plug it into the original. Plug it back into the original, see if it works. If you end up with 0 in the bottom, looking here, remember, if x is -1, then -1 is an extraneous situation, extraneous solution. Because when you plug in the -1, it doesn't work out. It would make a 0 on the bottom. If there's a 0 on the bottom, then you know it's an extraneous solution. So I look here, it's 10 as our x. Go ahead and plug in 10 up here. I think we're safe. It's not in the denominator. It's going to be 10 over 8. There's no 0 in the denominator. So we just put here. You got to put this as well. No, that's not extraneous solutions. Okay. There's no extraneous solution. If it made it equal to 0, I'd write extraneous solution there. That's all. That's the only difference. Okay. So we're going to look a little closer at 2 example problems doing the same steps. I want you to use these same steps for all the problems you do here. And let's see. Okay. Let's look at these 3 fractions. We have an equal sign, so we know it's an equation. Now, one thing you can always do is you can always just multiply all of the denominators together to get your least common or a common denominator. Is there anything else we can do? This grouping of x minus 4, it doesn't fit into 3. It doesn't fit into 1. There's nothing really happening that isn't common. So what I'm thinking here is we're going to take all of our fractions and go ahead and make a little bit more space on the top. Okay. So I set it up like this. I set it up like this to start. Okay. Now watch what I'm going to do. I'm going to say, okay, my least common denominator is all these things multiplied together. So we have minus 4 times 1, same thing. Okay. That's my least common denominator. Where should I put my least common denominator? To multiply what? fractions. It's going to be on the top of the fraction. Like, are you the opposite? So we have our LCD. We're going to go ahead and put it. Group everything. See how I'm grouping everything? 3 times x minus 4. 3 x minus 4. See, I put everything in the denominator, the least common denominator. I'm putting it up top here. Watch what's going to happen. Watch what's going to happen. Actually, go ahead and get to that point and cancel out what you can cancel out. What can you cancel? It's going to be different things for different equations here. All right. And double check with your neighbor if you're not sure what you can cancel. They should have a good idea for you. Everything on the top, these are all multiples. Times, 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 times. So we know that they're factors. We can cancel factors. So what can we cancel out? Who has one for me? Cancel out the 3s. I like that. Gone. Notice we just got rid of the denominator. We made it easier by doing this method. We get rid of the denominator right off. What's another thing? Yeah. X minus 4s. Gone. Good. Anything to do over here? That's 1, right? So watch. I've just gotten rid of all my denominators. Watch how straightforward this is going to be. Well, there's still a little bit of work to do, but what's 5 times 3? 15 is equal to 5 times 3 again, 15 times x minus 4. All right. Now I want you to think of a strategy from here. It's not like one more step will get you to the answer. These would be very difficult problems to try to do in your head. You got to write some of this down. Okay, so who has an idea of what I can try to do? At this point, I could see the path all the way. I could see the next step and then what's next. Can you start to see it? Yeah, Noah, what do you think?
Well, maybe if you start to do minus 15.
Well, if we move the 15 over, that you can always do, you could do that. I don't know if that's the path of least resistance. I want to teach you the path. So, does anyone else have another idea? We may end up doing that at the end. History. Yeah, John? Is that what you're going to say too?
Yeah.
Okay, so it all kind of came up at once. Sometimes when you're here and you're not sure what to do, but you see 2 binomials, you see the 15 and a binomial, or, you can go in and let's go ahead and distribute this. Let's FOIL this out. We're going to end up with a bunch of terms. We consolidate them. X method, answer. Okay. So, follow me. X squared minus 4x plus 3x, so it's minus x. Minus 12 plus 15. 15x minus 16. What term up here tells you what our method is going to be from here on out? Is there a term up here that, what? X squared. We know that x squared is our standard of the quad. It's at ax squared plus bx plus c, which we can make into 2 binomials with x method. So let's get everything, how about over to the left side? I'm going to subtract 15x minus 15x. I'm going to add 60. It doesn't matter where I add it. I'm just going to consolidate all those numbers. Left side, we've gotten rid of everything. It's equal to 0. And then go ahead and see if you can figure out and check with your neighbor, what is that trinomial going to be? It's a lot of terms, but you're just combining like terms and put it in order. So x squared is definitely out front. What else? Okay, check with your neighbor. Double check. Say, what do you have? Negative x, negative 1x, negative 15 together, negative 16. That just got rid of all this stuff. All right, negative 12 and positive 15 is positive 3, right? 15 minus 12. Positive 3 plus 60, 63. And now we're really ready. X method. Solutions will arrive from there. Okay, what gets us there? 63 multiply. Negative 16 add. What two numbers get us? 9 and 7. So positive 9, positive 7 gets you 63. But what's the other option?
Negative 9 and negative
7. There it is. So watch. Negative 7, negative 9. Multiply to give us positive 63. Add to give us negative 16. That's good. Those are the hardest ones to see. X minus 7. Who can see the answers now? X is 7. Or X is 9. Okay, those are our answers. Now we just got to check for extraneous situations. The only place that matters up in our original problem, when you check to see about extraneous situations, solutions, you're looking to see if it's going to make a 0 in the denominator. Here's the only place that can happen, x minus 4. If I plug in 7, 7 minus 4 is 3. Plug in 9, 9 minus 4 is 5. So we're going to write next to it, no extraneous solution. That's the modifier we got to put in. So you got to say if that's happening or not. Okay. So one more problem. I'll set you loose on the classwork. How do we feel so far? Thumbs up, sideways, down. You guys doing all right? Yeah, it's like here. Okay. It seems like we should have to do more, right? But when we have equations, we can just get rid of the denominators by multiplying it that way. Mark?
When you circle the final answer, is there a reason why the 7 and 9 are positive and not why are they not negative?
Right. Because what we're looking to see is here. We're looking to see, since these two expressions are going to multiply to give us 0, we're looking to see when they equal 0. So if I did that little step in between, I would go ahead and say, when does x minus 7 equal 0? I'm going to find out when it equals 0. Yeah. Then you add it to both sides, you see. So that's the same thing we're doing. X minus 9 is equal to 0. When you add 9, it's when x is 9. Okay. So let's do this last bit. If I multiply all the denominators together, I'm making my life way harder. You see, if I multiplied all these together, I'd make them harder. So what is a strategy you can have for finding the least common denominator? What value can we look at to maybe get an idea of? It'd be nice if it was what? K, but these don't fit into K, so it's not big enough. What's that? You got it? No. I said it. Which of my denominators would be nice if it was the least common denominator? You look to the biggest denominator. The biggest denominator, if the others fit into it, then you know that that's your least common denominator. It is going to be 6k squared. So all I need to do is rewrite these fractions. 6k squared, 1. 3k squared minus k. And then what I'm putting in here, go ahead and put that in there. I think you know now. What am I going to put in those parentheses? Just I've rewritten the entire equation out and input what we put in those parentheses. What do we put in? Okay, if you're waiting for it, I'm going to put my least common denominator in there. 6k squared. 6k squared. 6k squared. This, you see, allows me to get rid of all my denominators. And if you multiply both sides by the same value, you haven't changed anything, right? If you have 2 is equal to 4. You multiply both by 10. 2 is equal to 4. 1/2 is equal to 2/4. You get 10 over 2, you get 20 over 4, both of them are equal to 5. So as long as you multiply both sides by the same thing, you haven't changed anything. You haven't changed anything at all. Okay. What can I cancel out in the first fraction here? What can I cancel out? 6x. 6y squared, right? We have 1 left over. Now think of this as 6 is really 3 times 2. K squared is k times k. And on the bottom we have 3 times k times k. So which can we cancel out? What can we cancel out there? 3's. What else? K's. So on the bottom, this gets rid of everything. All we have left over on the top is 2 minus. You see, the bottom was all canceled out. That's why we use the least common denominator. We're going to always cancel everything on the bottom. Always cancel everything on the bottom. Okay, how about this one? This is 3 times 2 times k times k. That's 1k. So what should we cross out there? Just 1k. And then we have 6k. We're getting there pretty quick. Next step. Let's do it. Minus 2 minus 2. Negative 1 is equal to negative 6k. It's negative 6 times k. We divide by negative 6. K is equal to, what's a negative divided by a negative? Positive 1/6. Okay, we're going to look to see extraneous situations. If I plug in 1/6 here, I'm fine, right? What value would I have to plug it in to make a 0 down here? K would have to be what? The only way to get a 0 in the denominator here is if k is 0. If k was 0, then we'd have a 0. If k was 0, we'd have a 0. 1/6 is fine, so I just need to write no. ext, extraneous, solutions, SOL. Okay. I was in the way there. So just to break it down again the whole time, huh?
Okay.
The whole time. We're looking at the least common denominator. We looked at the biggest term in the denominators to see if it fits. We did see it fits. So I multiply at the top. Actually, I multiply the fractions by 6k squared, which puts it at the top. Cancel out what you can. All denominators are gone by this step where you have to solve. All denominators gone. Solve it out. Isolate your variable all the way to k. Just double check. Extraneous situations. No. Done. All right. Doable, right? Very doable. Okay. That's actually easier than I thought it would be. Because you can just multiply by that on the denominator part. Okay, give me some thumbs up, sideways, down now. How we feel? Pretty okay? Okay to good? Okay. All right, guys, subscribe. Please subscribe. You can come to our hot chocolate party. Mm.